So when we first started talking about some of the characteristics of a parabola, we talked about how the vertex can either be the highest point or the lowest point on a graph. And so in math, a lot of times we want to know about that high point or that low point. And so we call that a maximum or a minimum. So the maximum and the minimum is always going to be the y coordinate of the vertex, because when we're talking about the maximum or the minimum, we're talking about the height. What is the highest point on the parabola, or what is the lowest point on the parabola? And height is measured along the y-axis. Now, something that you're going to see often in math, and we've talked about this a little bit when we talked about functions in general, is anytime they ask you a question about what, that's going to be the y value of your ordered pair. So if I say, what is the maximum value? That's going to be the y value. If I ask you a question about where something happens, that's going to be looking at x values. So where does the function have a maximum? That would be your x. What is the maximum? Would be your y. Or this we've already talked about a little bit when we said, where is the function increasing and where is the function decreasing? We describe that from left to right, looking at the x-axis. So anytime it's a question about what is it, you're going to want a y value. If you're asking where it happens, that's going to be an x value. And that's a really good thing to kind of memorize and have in mind as we're going through these things. So the maximum and the minimum, again, that's going to come from the vertex. So we're going to use the same formulas and things that we've talked about to determine the vertex. And so that's going to be the first thing that we do. So the first thing it asks is tell us whether or not the function has a maximum or whether it has a minimum. It can't have both. It's going to be either one or the other. And remember, this is going to be looking at A. So it's going to be a maximum if the parabola opens down, and it's going to be a minimum if the parabola opens up. So if it opens down, that means you have a negative A value. And if it opens up, that means you have a positive A value. So if we look at number 6, A is -4. That means that my parabola opens down. And so because this is going to be the very highest point on the parabola, that's how we know that this function is going to have a maximum. Take just a second to look at number 7, even though we haven't gotten there yet, and kind of decide for yourself, do you think that's going to be a maximum or a minimum? And so again, what we look at is A, and since A is positive, it's going to open up. So if you thought that that was going to be a minimum, then you are correct. So the first thing that we need to do is figure out the vertex, and then we can decide whether the answer we want is the x or the y. So remember, to start with the vertex, we have to do our negative b, or the opposite of b, over 2a formula. So b is -24. That means the opposite is going to be positive 24 over 2, because it's always 2, times a, which is -4. Well, 2 times -4 is -8, and so 24 divided by -8 is -3. And remember, that's the x. So now to figure out the y, we need to plug that into our equation. So we're going to do -4 times -3 squared minus 24 times -3. This is just the equation that we were given, f of x, minus 19. And I got to grab my calculator. You can type that in. If you're going to put it in your calculator, make sure that you put the parentheses around the -3 so that the calculator reads the base correctly. So -4 times -3 squared minus 24 times -3 minus 19, I get 17. So the vertex is at -3, positive 17. It asks, what is the maximum? So remember, what is the y value? That means we want this number. So the answer is that the maximum is equal to 17. And that's all you have to do. We're not graphing it. We're not doing anything. We're just using the vertex and deciding which piece of it we need. So number 7 is a minimum, but that doesn't change the process any. It just means that when you find your answer, it's going to be its minimum value instead of its maximum value. So go ahead and pause the video and find the vertex and see if you can decide what the minimum value is here. So what you should get for your x value is 1/2. Remember, we use the negative b over 2a formula. So since b is negative 8, it becomes positive 8 over 2 times 8. So we get 8 over 16, which reduces to 1/2. So you can either put 1/2 into the equation, or since 1/2 comes out exactly, you could plug in 0.5 if you would rather in your calculator. If it was 1/3, remember we couldn't do that because there is not a decimal that's equal to 1/3. But go ahead now, if you haven't already, we're going to plug in that 1/2. The result should be positive 4. So that means that our vertex is at 1/2 positive 4. And the graph is a minimum. And because we want to know what the minimum is, that means that we want the y value. And so the minimum of this function is going to be 4. So it's just a calculation. It's not too bad. So now, if we look at this last example here, this is one of the big reasons why we need to be able to use quadratic functions, is because there's lots of things in the world that are shaped this way. Sometimes things are way too big to conveniently measure, like we may not have a tape measure that can measure thousands of feet. And so instead we use math to try and calculate that height. So this is talking about the Mackinac Bridge that you can find in Michigan. It says the suspension cables between the two towers form a parabola that can be modeled by this equation. Now this has really ugly numbers, so obviously you're going to need a calculator. It says where x and y are measured in feet. What is the height of the cable above the water at its lowest point? And so what it's asking us here is, at its very lowest point here, what is this height? Well, that by very definition is what we're finding when we find the minimum. And so that's what we're going to do. We're going to use this equation with those ugly decimals to calculate the minimum of the function. So let's start first by finding the x value. Go ahead and pause the video and find the x value and see if you can do it correctly. When I do that, I come out with 1,887.76. Now, one thing that's really important, if you type this all straight into your calculator, you need some parentheses in here in order to make sure that it does it correctly. So you can say 0.37 divided by. Now you have to put parentheses around the 2 times 0.000098. Without those parentheses, it's only going to divide by the 2. Then it will multiply by the other thing instead of dividing by both of them. So if you didn't get the answer that I did, it's probably because you typed it incorrectly. So now we want to take 1887.76 and plug that into our equation to solve for y. Go ahead, pause the video and do that, please. So we get a y value of 202.8. This means that the vertex of that parabola is going to be 1,887, roughly 88 if we want to estimate, and 203 if we want to just go to the nearest foot. It didn't tell us what to do, so that's probably fine. So if we want to know, again, what is the height, what is always talking about the y value? So that's going to be this one. So the minimum height, the lowest point, is going to be 203 feet above the water. That's the answer that we're looking for. Now, if it said, how far across the bridge does it meet its minimum height? Well, that would be where. So that would be at about 1,888 feet going this direction. And you can see that that's right about where we landed on the graph there. So that's going to be the end of that. And tomorrow's going to be just a day to practice everything and review. And I will see you all tomorrow, Monday.